All right, welcome to Mrs. Pessy's first lesson. This is for section 4.4, which we are still dealing with exponential and logarithmic functions, but now we are solving them. So we are talking about exponential and logarithmic equations. So what we're going to do first today is this idea over here that's copied from your book, solving exponential equations by expressing the powers the same as equal if the bases are the same. So the idea is if the bases are equal, the exponents are equal. So if you have 2 to some power equal to 2 to some power, then those two powers have to be equal. And that's the example that's in A. They have 2 to the 3x minus 8 equals 16. If you rewrite the 16 as 2 to some power, which is what happens down here, then if I have 2 to the 3x minus 8 and 2 to the 4th, then 3x minus 8 must be 4. And then we have an easy equation that we know how to solve. So what you have to know for these really are the different bases and their powers. So it might seem kind of silly to take the time to write them out, but if you just think through what some of these common ones would be, so the ones that we'll use most often, then that really will be helpful. And nothing ever gets too crazy big. So 2 to each of these powers, 3 to each of these powers, and maybe 4 and 5. So where we are, 243. So, and as I'm taking these notes, I hope that you're taking these notes, because these are the new things that you have the pleasure of learning. And you can pause me and you can rewind me and you can try to decipher my handwriting with my fancy new pen that I got so that I could write all of this important stuff out for you. So 5 squared is 25, 5 times 5 times 5, 5 to the third is 125. I don't think it's going to get a whole lot higher than that. But just because we took the other ones out to the 5th, we'll take this guy out to the 5th. So this is one of 3 types of problems that we'll solve here. Since overwhelmingly we liked the idea of having homework online, we just couldn't agree on which platform. This is the list of book problems that we had, so I'll work through a couple of these examples. If you want to work out the others, it originally was going to be that the evens would have been homework, and I'll start working out some of these. I can take a copy of my answers and add it to these notes so you have them just to practice with. So I won't check it, but I'll work through maybe every other even here. So starting with number 2, 3 to some power is supposed to be equal to 81. So if you recognize what that power is, life is good. You can just write down what that value is. But if we just use this to think of the process that we're using here, if the bases are the same, the exponents have to be the same. So there's just no solving on this one. X has to be equal to 4. No other work to do. We'll skip 4. We'll move on to 6. So if we say 3 to the 2x plus 1 is 27, and we know that we can rewrite 27 as 3 to the 3rd power, then I know that 2x plus 1 has to be equal to 3. Subtract 1 from both sides. 2x is 2, divide by 2, we get that x is equal to 1. If we go back and check that answer, 2 times 1 is 2, plus 1 is in fact 3, and so that answer works. That x is equal to 1. If we move to something like number 10, so again, just doing every other even instead, there's a little bit more work that goes on here. because we have 4 to some power equals 32, and we can't rewrite 32 as a base of 4, but 4 can be rewritten as a base of 2. So if you rewrite 4 as 2 squared to the x, and 32 we said was what, 2 to the 5th? Then we can think of our exponent rules. This really is just a power to a power. You could have not written it out that way in the first step and gone directly to this one. But again, just to remember those rules. So 2 to the 2x equals 2 to the 5th. And so my powers are 2x and 5. If I set those equal to one another and divide both sides by 2, then I get that x is equal to 5/2. Okay, so sometimes it requires switching both of them, not just one of them. 14 has a little bit of crazy that happens in it as well. 5 to the 2 minus x and 1 over 125. So this again really just testing our knowledge of exponents here and what we remember that to mean. So it's a base of 5, so life is good. But this 1 over 125. Again, if I wanted to do it in 2 steps, just to, take my time because I have time these days. So 5 to the 2 minus x, I could rewrite that as 1 over 5 to the 3rd. And then I have to remember that whenever I have fractions, I can rewrite them as negative exponents. So if that moves to the numerator, it just has a negative exponent. Okay, so then x would be equal to 5 for that one. A little bit of a technical glitch there. Hopefully that wasn't too crazy. One more just to review exponent rules. If we look at number 18, this one said 9 to the x is equal to 1 over the cubed root of 3. And so 9 can be rewritten as 3 squared. So again, those exponents would multiply and I would end up with 2 to the x. And my fraction with my radical can be rewritten as 3 to the 1/3. And so whenever I move that to the numerator of my fraction, it makes it 3 and negative 1/3. So 2x equals negative 1/3. What? If I divide both sides by 2, that's the same thing as multiplying by 1/2, since I have fractions over there. So for all of you that should love fractions more than you do, you end up with x equals negative 1/6. I don't know what that is as a decimal point. I don't care. I like it as a fraction. So again, these problems, I will take a copy of my work, which is all of the even problems, and share it alongside a PDF of these notes and then the link to the video on YouTube. And if this works, this is what our notes will look like for the foreseeable future.